All right, so today's lesson is going to be kind of quick and easy. Important, but quick and easy. So it's just this one sheet. We're talking about identifying basic transformations. So you did an entire transformation unit that involved most of these words: translations, reflections, rotations, dilations. And before we get into really anything with the details of it, I want to do kind of like a big overview of it to make sure that we're on the same page and to try and make you remember it. So the four main words were translation, reflection, rotation, and dilation. A translation is a move or a shift or a slide. All right? And depending on kind of what context you're doing and what subject of math you're applying this to, we kind of use each of those words differently. But really what you're doing in these is you're taking some what's referred to as, maybe you remember this, pre-image. So this appears to be a rectangle A, B, C, D. And you're translating it, you're moving, you're shifting, you're sliding it over here to A prime, B prime, C prime, D prime. All right, and this is referred to as the image. So this was the pre-image. I'm not going to be able to fit that. And this is your image. So pre before, right, and image after, sort of. So your pre-image slides over. It looks exactly the same. It's just in a different spot. All right. The second one is a reflection. And really, when we're looking at this, this is a line reflection. You can flip things over a line or you can flip things over a point. And they have some different characteristics, but the line reflection is the main one. So it even has it written in here. Maybe you'll see it on the notes. It's a little small here. All right, you have the pre-image of this triangle ABC. All right, you're reflecting over this line. All right, so this line K here is your line of reflection. You may have even learned how to construct that from your teacher last year or this past year. All right, so you're gonna now it flips over. So now you have A prime, B prime, C prime. A is the same distance from the line as A prime is. These are the same distance, C and C prime. So sometimes, like if you flipped it over the y-axis, you would count. Oh, it's 1, 2, 3 of the y-axis, so it's 1, 2, 3 on the other side. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's where you put A prime. All right, perpendicular in, perpendicular out. All right, so notice so far this rectangle and this rectangle look like they're the same size. This triangle here and this triangle here, while flipped, look like they're the same size. Your teacher last year might have even talked about the orientation of the letters. How here it's clockwise, but on a line reflection it flips and now it's counterclockwise. All right. Rotations. All right. A rotation, so reflection was a flip. All right. Or reflect, but then we're not going to use the same word. A rotation is a turn or a spin. All right. Now, without getting into too much here, there's a point around which everything spins. All right. And there's a direction and an amount. All right. So positive goes this way and negative goes that way. All right. Now, how do you measure that? A certain number of degrees. All right, so you measure your rotation by the number of degrees of the turn. All right, so this is a positive spin. All right, so here's your pre-image, and then here's your image. All right, and then your dilate, and again, these look like they're the same size. Same size, same size, same size. Ooh, not the same size. All right, and that was the last one that we're going to talk about, which is a dilation. All right, dilation, if I'm going to give you a word, is to scale or to resize. All right, so in this case, your pre-image was here, and it got bigger. All right, it scaled it up, it resized it larger. It doesn't have to be larger. All right, it could make the image could wind up being smaller. Excuse me. All right, and we'll talk about that when we get into the details of dilations, because that's when you're talking about scale factors. All right, so you have something called center of dilation, which is the point from which everything blows out or shrinks in, and you have the scale factor. But we'll get into that more down the road. All right, so one last thing. Same size, same size, same size, not the same size. So dilations generally are not rigid motions. Not a rigid motion. All right? So, and a rigid motion, this is an important word. When the pre-image is congruent to the image. So whatever you do, all right, big word. All right, whatever you do to the pre-image, if it works out to be congruent to if the image works out to be congruent to it, you're dealing with a rigid motion. But with most dilations, and there's like one or two exceptions, all right, with most dilations, you're going to change the size, whether bigger or smaller. So that is an example of a transformation that is not a rigid motion. Rigid motion, rigid motion, rigid motion, almost always not a rigid motion. All right, so that's going to be important too. All right, a rigid motion when the pre-image is congruent to the image. And there's other things like the angle measures are congruent and the sides are in proportion. But we'll get to all that when we're dealing with similarity here. All right, but with rigid motions, the angle measures are the same, the side lengths are the same. There's a lot of properties on that are important, and I'm sure your teacher stressed that throughout the year. All right, so that's it for this. Kind of a short and easy, quick one. Just one video today. And then I will have the Castle Learning assignment probably posted by, well, I'm recording this on Thursday, so probably by Thursday night. And it'll include this stuff and what we did today, which was the vertical angles and parallel lines, if memory serves me right. Good job today, by the way, on the conference. I thought that was excellent. I hope you liked it or got something out of it at least. And that's it. All right, have a great day. Enjoy it. It's going to be beautiful outside, except for today when you're watching this, because I think Friday is going to be miserable. So I'm going to stop talking about the weather. Take care.